In the 4th century BC, there were many important places and powers in the world. It was a time of significant political, cultural, and intellectual change. In Greece, the city-states were grappling with the aftermath of the Peloponnesian War, which had left many of them weakened and divided. At the same time, the rise of Macedon under the leadership of Philip II and his son, Alexander the Great, was transforming the political landscape of the Mediterranean world. In southern Italy, there was a city named Tarentum. It was a Greek colony and had a famous school for learning. At that time, many city-states in Greece were weak from a big war. Around 428 BC, a person known as Archytas was born in Tarentum. Archytas of Tarentum was an ancient Greek philosopher, mathematician, scientist, engineer, statesman, and strategist from the city of Tarentum, now modern-day Taranto in Italy. As a prominent figure of the Pythagorean school, he made significant contributions to various fields. His family background is not well documented, but it is believed that he came from a prominent and well-to-do family. As a young man, Archytas was drawn to philosophy, mathematics, and science, likely influenced by the Pythagorean school, which emphasized the interconnectedness of these disciplines. He was a student of Philolaus, who was a well-known philosopher in the Pythagorean school of thought. Archytas believed in the fundamental harmony and interconnectedness of all things. He shared the Pythagorean view that the universe was governed by mathematical principles and that the pursuit of knowledge was a lifelong endeavor. He also held that it was possible to achieve wisdom and understanding through philosophical inquiry. Archytas' philosophical ideas had a significant influence on Plato, who studied under Archytas during his visit to southern Italy. Plato's dialogues, particularly the Timaeus, show the impact of Archytas' teachings on Plato's own philosophical ideas. Archytas' emphasis on the importance of reason and the interconnectedness of all things resonated with Plato and helped shape his metaphysical and epistemological views. Archytas dedicated his efforts to solving one of the three great problems of the Greek mathematical world: the duplication of the cube. The challenge entailed constructing a cube using only a compass and straightedge that possessed twice the volume of a given cube. However, it was later discovered that a solution under these constraints is impossible, but in making the effort, Archytas evolved theorems concerning means, that is, lines or values midway between two extremes. He ingeniously solved the problem through a three-dimensional construction, making use of tools that were not quite allowed according to the strictest rules. His solution involved the use of a spiral curve, demonstrating his innovative and creative approach to mathematical problems. He was the first Greek mathematician who used math in a practical way, such as when he created a theory about sound and pitch. He came up with the idea of a harmonic progression, 1, 1/2, 1/3, 1/4, and so on. This work, which included both rational and irrational numbers, was important because it set the stage for the development of more advanced mathematical concepts. As a Pythagorean, he was fascinated by the possibility of creating semitones, or half-steps, using mathematical principles. He was able to divide the octave into 12 equal semitones, laying the foundation for the modern piano. This work was influenced by the study of musical intervals and the relationships between the lengths of strings and the pitches they produce. By that, he developed a mathematical theory of harmonics, which helped explain the phenomenon of consonance and dissonance in music. He thought that the pitch of a sound depended on how fast air vibrated. He was correct about this, but he didn't fully understand the idea of wave motion. Archytas believed that high-pitched sounds moved faster through the air than low-pitched sounds. One of his most notable mathematical achievements is Archytas' theorem, which states that in a right triangle, the length of the line segment between the midpoints of the hypotenuse and one of the legs is equal to 1/4 the length of the hypotenuse. This theorem has implications for the study of conic sections and the development of analytic geometry. He is credited with inventing several mechanical devices, including a water clock and various types of pumps. His most famous invention is the pigeon or artificial bird, an early example of a flying machine. Although it is unclear how the device functioned, it is believed to have been powered by steam or compressed air, demonstrating Archytas' innovative and inventive spirit. That is one of the earliest known automaton, or a self-operating machine, in ancient Greece. The idea of automata has a long history that can be traced back to ancient times. The concept of automata has fascinated humans for thousands of years. From ancient Greece to China, people have been captivated by the idea of creating machines that can move and operate on their own. These machines have taken many forms, from simple devices that mimic animal movements to complex robots that can perform tasks and interact with their environment. Additionally, he is credited with inventing the pulley system. His multidisciplinary achievements left a lasting impact on ancient and modern science, mathematics, philosophy, and warfare. Archytas' life and works demonstrate the importance of curiosity, creativity in the pursuit of knowledge. His ability to synthesize ideas from various disciplines and apply them to practical problems reflects the interconnectedness of all fields of study and the potential for cross-fertilization between them. In a world that often compartmentalizes knowledge and discourages interdisciplinary exploration, his life serves as a reminder of the value of a holistic and integrated approach to learning. By embracing the connections between seemingly disparate fields, we can unlock new insights, solve complex problems, and enrich our understanding of the world around us.